this R1 is going to be once again NHS. But the point is here today we will also add this new branch, and this R5 will be your NHC, but you will be configuring netting onto R4. Means that your NSC will be behind net. As I said that in DMVPN it is also possible that you can have NSCs behind netting, network address translation. It is not mandatory that they must have a static public IP address or something like that, right? The only thing that they will require that they must have reachability with NHS, right? So I'm going to perform. See, I have removed all existing configuration from all devices related to DMVPN and routing protocols, right? The only thing that is configured right now onto all devices, like their IP addresses, the default route towards an ISP. Even we can also move on to R4, and first of all I have to do configuration of R4. Do show IP interface brief. Incorrect IP address is configured onto FA0 by 0. It should be 192.168.45.4. IP. Now the point is here it must have a static default route towards ISP, right? So it is having that 44.1.1. so it's communicating today, right? Ping 11.1, which is hub's public IP address. So today R4 do not have any kind of problem, right? Yesterday it was not able to even communicate with its on subnet as well. So now it is working fine, there is no problem at all. And now we are going to configure netting over here, right? So what will I do? I'll say FA0 by 0 IP net inside interface serial 1 by 0 IP net outside, then create one access list, one permit any, and then IP net inside source list to 1 interface serial. I'll configure pat actually, right? And then I'll say overload. Now you can configure this command as well. So IP net summary, so IP net statistics. In it will show you that okay, outside is configured onto this one, inside is configured onto this one, then ACL one is there, and all these things, right? After doing this configuration, now from R4 even you must be able to communicate with 11.1.1.10 where when it's your source is what FA0 by 0. Then also you must be, it means that netting is configured perfectly. So IP net translation, see, it's not it, which means now you can see from the lane interface it can communicate with 11.1.10. however it does not have reverse path, right? Yeah, it is having reverse path, but only for 44's network, not for any other network, right? Like ISP router doesn't have any information about this 45's network, right? So now what will I do? Because yes, it is having default route. Finally I have to do the configuration in perspective of R5 as well. So I have to move on to R5, and then let's configure this R5 as well now. So onto R5's F0 by 0 you are going to configure an IP address like 192.168.45.5. 192.168.105.1. Right, fine, but it cannot communicate with internet. It cannot reach, it cannot access internet right now. You know why? Because it does not have the default route over here, right? Now you can also configure one static default route onto R5 towards R4, but in that case how will it be possible for R4 to reach 105? Or however it is not necessary for R4 to reach the NSC's NSC's lane, which is 105.0. You understand? So what can we do here? We can on to R5 and I can simply configure a static default route, right? IP route 000 000, and next hop is going to be 45.4. That's fine actually. You know why? Because 45.5 will be directly connected to R4, so there will not be any problem related to reverse path. Now to configure, to confirm it, what can we do? We can try to ping with 11.1.10 from here as well. So it must be able to communicate with that. See, it must be able to communicate with 22.1.10. It must be able to communicate with 33.1.10. That's fine. That's what we wanted actually.
R40 must be reverse path.
Yeah, of course, because 45 network is directly connected. We are not communicating from the lane of the R5, no.
Okay.
Because lane, they will exchange their lane information with using tunnel now. So I don't need to worry about this lane, right? Fine guys, I'm going to configure now VPN, DMVPN, right, onto all devices. Fine. So I will start it from R1. I'll say interface tunnel 1 IP address is going to be, tell me, 1.1. Then tunnel source is going to be serial 1/0. Tunnel mode GRE what, multi-point, right? And then you will say IP and HRP, and then network ID, let's say it is 10. Then IP and HRP authentication is going to be Cisco at 1 2 3. Oh my god, Cisco 1 2 3. My fine. Then IP and HRP map multicast what, dynamic, do show run interface tunnel 1, and along with that I will also configure that command IP and HRP redirect, do show run interface tunnel. I will not leave any command now, right? I have configured everything over here now. Apart from now, after doing this configuration, let's move on to R2, which is POP1, interface tunnel 1. IP address is going to be, tell me, 1.2. Then tunnel source is going to be serial 1/0 itself, and then tunnel mode is going to be GRE, because I'll configure fully matched, right? And then after IP and HRP network ID is going to be like, you can take any number. Then IP and HRP authentication is going to be Cisco 1 2 3. Then you will be saying IP and HRP map under overlay address, which is 1.1, and then underlay address, which is 11.1.10 of hub, right? Then you have to tell about IP and HRP NHS, and which is your 1.1 itself, right? Because 1.1 is going to be your NHS. Do show run interface tunnel 1. Check it out. So we have done all this configuration. Apart from that, you can also do this configuration as well, IP and HRP shortcut. Now it must you do one thing, say shutdown, and once again you can say no shutdown. One more thing that is also necessary over here, IP and HRP map multicast. Which one? Tell me. Right? Do show run interface tunnel 1 for multicasting, to allow multicast, right? And then say no shutdown. So it will register itself onto hub now automatically, and now you can move on to hub and you can say show DMVPN. You must get that entry over here automatically. Show IP and HRP, you must get automatically unique registered used, right? So of course it is registered now, right? Now you can do one thing, you can move on to R3 as well, and then on to R3 you do one thing, say sorry, interface IP address is going to be now, tunnel source is going to be serial 1/, tunnel mode is going to be multi-point, sorry, GRE multi-point. Then IP and HRP network ID is 10, IP and HRP authentication is Cisco 1 2 3. Then IP and HRP map 192.168.1.1 and then 11.1.10. Then IP and HRP map multicast 11.1.10. Then IP and HRP what?
NHS.
Shortcut. Then IP and HRP NHS, right? NHS, and then NHS IP address is what? 1.1. Do show run interface tunnel 1. Now it must register itself onto hub. Let's move on to hub and we must get it over here. Yes, it have also registered it, right? See 1.3 and 33.1.10. Finally, I'll move on to R5, and I'll also configure this R5, right? Interface tunnel 1 IP address is going to be, let's say here I configure 1.5, and then tunnel source is going to be F0 by 0. Then tunnel mode is going to be GRE multipoint. Then here you have to say IP and HRP. Tell me network ID is what? 100 IP, and HRP authentication is Cisco 123. Then IP and HRP map 191.68.1.1, and then 11.1.10. IP and HRP map multicast 11.1.10, and then after IP and HRP shortcut, and then IP and HRP NHS is going to be show run interface tunnel 1. Check it out, that is there any command which is left? I don't think so that there is any command that we have skipped from here. So now it must be able to register itself onto here, and you see that it have also registered itself. See, 1.5 is coming from, see, NBM address is 45. However, claimed NBM address was 45.5 because this is behind netting. Even if you say DMVPN, show DMVPN, it will show you that it is DN. DN means netted, D dynamic, and for netted. Right? So it is also possible to have your NSCs behind netting as well. So there will not be any problem. The only thing that is mandatory, that reachability should be there, right? Then after it, you do one thing, move back again on R1 and configure your, this time today let's configure Ospf, right, in place of EIGRP. Let's configure Ospf. Will there be any problem now? See, we have configured all options of EIGRP in previous class, right? So today we are going to configure Ospf in place of EIGRP over DMVPN. So do one thing, say router Ospf 1, router ID is going to be 111, then say network 192.168.1.0, and area is going to be 0. Then onto its FA 0 by 0, IP Ospf 1 area 0. That's fine, right? Then after you do one thing, you can try to see this command as well. You see that Ospf has enabled onto tunnel as well as on its LAN interface. Then after it, move on to R2 and then say router Ospf 1, router ID is going to be 2.2.2, interface tunnel 1, IP, tell me IP Ospf 1 area is going to be 0. Then onto its LAN interface as well, and then you show history, because these commands will remain same. So I'll copy and paste onto other devices. Router Ospf 1, router ID is going to be now 3.3.3, and then remaining commands will remain same. Now onto R5, router Ospf 1, router ID is going to be 5.5.5, and then now the problem is, see what is happening now. Adjacency are getting, exchange to downloading to full down everything. What? Sorry. Fine. See, neighborship will not come up. You know why? By default onto tunnel interfaces, your network type of Ospf is point to point. And in this multi-access network, you are having more than 2 devices. So, and all of them are having their network type as point to point. That is why neighborship will not come up. See. You have to make it, let's make it broadcast now. Because this is kind of NBMA, right? Sorry. Yes, that's done. And let's make it onto all devices. Now there will be DR and BDR election. But only R1 is there who is having neighborship with all others, right? Show IP Ospf neighbor and it is still in two-way state. Now in case if R1 does, if R1 is not elected as a DR, then there will be a big problem, big issue, because only DR can exchange routes in between two DR others. Let's say that R4 is there, DR, or R5 is DR actually. Let's say R5 is DR. You do one thing, move back again onto R1. See who is DR? 5 is DR, and it means that it have become itself as BDR. This R1 itself have become now BDR. So the problem is now that R5 is the only router who will be responsible to exchange updates in between two routers in this multi-access network. But R5 is having neighborship with R1 only. It does not have neighborship with R2 and R3. Due to hub and spoke behavior, because Ospf neighborship cannot come up in between spoke to spoke. No, Ospf neighborship will always be formed in between hub and spoke only, right? So now you will see that between two DR others like 2 and 3, they will not be able to communicate, they will not be able to access their prefixes with each other. As you can move on to R2, you can check show IP route. See, 103 is directly connected. It have learned 105, it have learned 101, you understand? But it have not learned 102 and will not learn, and it is not possible, right? So now question is that how will you solve this kind of problem in DMVPN? Remember that if you are going to implement Ospf over DMVPN, and if you are using network type broadcast, make sure that you are configuring your hub as a DR. And to achieve that, do one thing, move on to move on to spokes and configure their priority as 0, so that they will not participate in DR and BDR election, right? And here in this hub and spoke topology, there will not be any need of BDR. There will not be any requirement of having BDR. So move on to R2, IP Ospf priority 0, on to R3 as well. Right? Fine, no problem at all. Move on to R2. See, no problem. Show IP Ospf database. There will be one network LSN. They will be removed actually, because right now only R1 is working as a DR. Don't worry, these LSS will be removed under an network LSS, right? However, it is having 4 router LSS because they are having, tell me, we are having right now 4 routers participating in this area 0. Any problem? Right? So this is that how we can configure Ospf over DMVPN. In same manner, you can also configure BGP over DMVPN. In BGP, you don't need to do anything else, because now they are reachable via tunnel interfaces. You just need to define your neighbors statically now. However, it was also possible for you to have to use your network type as point to multipoint as well in place of broadcast. Like you can move on to all devices. So tunnel interface IPv6 network is what? Point to. Configure it onto all devices now. But now convergence will be slow as compared to broadcast, because in broadcast timers are 1040, whereas in point to multipoint it is 30 and 120. But again, there will not be any problem. See, swipe it out. It will start to receive. See, 105 is there, 101 is there, and 103. Where is 103 actually? This is 103, right? And very first time you will always go via 191.68 trace route, 191.68.103.1. But next time, because you are using phase 3, we have enabled phase 3. Do you remember? Now finally, DMVPN is done now. The only one thing is left in DMVPN, that how to secure it, right? Because still traffic is going in secure way. Your traffic is not secure, right? When it is going via ISP from one branch to another branch, it is not secure. To make it secure, I'll be doing some configuration, but later on I'll secure it, right? So after it, let's go for site to site VPN now. Let's say there is one site, there is another site, this is your ISP, these are the interfaces that we are going to use over here. Fine. The point is, if you are going to configure site to site VPN, again it will be a point to point VPN, and it will allow only LAN users to communicate with each other of two remote offices in a secure way, because you can also call it IPsec VPN. So we are going to configure now this IPsec VPN. The problem is that if you are not configuring site to site VPN, if you have configured only GRE tunnel in between two remote offices, because you can also transmit your data from one remote office to another one via GRE tunnel, but that is completely insecure way. Anyone can capture your traffic and can read that information, right? Can also modify your data. So basically, if you talk about the IPsec VPN, it is used to provide data integrity. data encryption. Right? Data integrity, data encryption, and what?
Authentication.
Yes, of course, authentication as well, and anti replay. Right? These four things will be provided by IPsec VPN. What do you mean by data integrity? Data integrity means that your data is alter-free data. No one have altered your data, which means data integrity. Right? Encryption means it will go in the encrypted form. It means that if you do not have the key to decrypt your data, you will not be able to read my data. See, modification is different thing. Like anyone can modify data, and reading, I mean anyone can read data, it's different thing. These two things are different from each other. Do not compare your data integrity with data encryption, because data integrity is just to ensure that is it alter free or it is altered data. That's it. Whereas data encryption ensures that attacker should not be able to read my data. It will change the format of your data, right? Authentication. We have to authenticate this thing that, okay, are these packets coming from the valid source? Anti-replay. This is the feature which is used. Like, sometime what happens that attacker will capture your data, will make some changes, will again put it onto network, will place it again onto network, and those packets will be delivered onto destination now. But destination can check, okay, these packets should have received within this time period. If they were not received within that duration, within that time period, then it will think that, okay, no, someone have done some illegal things, so it will simply drop your data with using. This is the meaning by anti-replay. See, whenever you are transmitting data via IPsec VPN, it will set some timestamp onto that. It means that that packet should be delivered onto destination within that time period. If your packet was not delivered within that time period, then destination will never receive that traffic, will never receive that packet. That's the meaning by anti-replay. So basically, IPsec VPN will provide you data integrity, data encryption, authentication, and of course anti-replay. You understand? Now, if you are going to learn about this IPsec VPN, here there are two main things. Actually, IPsec VPN works into two phases. Phase 1 and phase 2. Phase 1 will always be performed by ISACamp. Phase 2 will always be performed by IPsec itself. ISACamp is Internet Security Association Key Management Protocol. IPsec. Right? So phase 1 will be performed. If one more thing, that if phase 1 does not come up, then phase 2 will never be initiated. Phase 2 will be initiated in that condition only if phase 1 have came up successfully. Phase 1 will be performed by ISACamp, and ISACamp is going to use UDP port number 500 for itself, And one more thing, ISACAP in itself is not a protocol, it's a protocol suite, just like TCP/IP suite. In same manner, ISACAP is a what? Protocol suite. It will be using something like, let's talk about phase 1 first of all. This ISACAP, or you can say phase 1. It will be responsible to perform authentication, peer-to-peer authentication. It will be responsible to identify that whether this user, because tunnel will be formed in between two end users, right? In between two remote devices. So how will you confirm that this remote device is a valid user? So for that purpose, it will perform authentication and all these things, right? So for that purpose, here we are having this phase 1. So basically in phase 1, it will confirm, actually in phase 1, they will perform ISACAP SA. SA is Security Association. ISACAP SA, Security Association. And in this Security Association, we are having so many parameters. Like for authentication, what will you use, right? Like for authentication, if you talk about the authentication, we can use anything to perform authentication out from these mechanisms. Like we can use a pre-shared key. Pre-shared key. We can use RSA encryption key, RSA signature as well, I think so. Something like that. But in CCIE RNS, we are having authentication of, with using pre-shared key only. So here we are going to use pre-shared key for authentication, right? In same manner, if you talk about the hashing is used for data integrity, right? Hashing is used for data integrity. Like it will create a hash value of your packet, entire packet, will put it over there, and then whenever a receiver will receive that, will again calculate the hash value of that received packet and will compare that hash value which came with that. If both of them are matching, then it means data is alter free, and if it is mismatched, it means someone have altered your data, right? So it will discard your packet. For hashing, we are having either MD5 or SHA. SHA is the latest one, so I'll be using. These all are components of ISACAP Security Association, right? Like authentication, hashing. Along with that, it is also having encryption. For doing encryption, you are having so many algorithms over here. Like you are having dash, 3 dash. You are also having AES. AES is the latest one. However, you will always select that one which is supported by both remote devices, right? These parameters must be same on both sides. Then only phase 1 can come up. Otherwise, phase 1 will not come up. Like if you are using pre-shared key, then pre-shared key must be common onto both ends. Hashing algorithm must be common onto both ends. Encryption algorithm must be common onto both ends. Either dash, 3 dash or AES. But AES is the best one. Then you will define your Diffie-Hellman group. Diffie-Hellman group. We are having so many groups like 1, 3, 5. Some other groups are also there, right? Higher is always preferred. And now you can ask me that what is the uses of Diffie-Hellman group over here? Actually, in phase 1, they will exchange their parameters with each other. But how will it be possible to exchange those parameters in a secure way? Because if anybody else comes to know that, okay, what parameters you are using over there, right? Then also it is dangerous for you. So to make it secure, actually, it will be using Diffie-Hellman group, right? And higher is always preferred. And according to question you will be configuring it, right? If they ask you that okay, your group must be 128 bits long, then you can see that okay, for 128 which group is there, or 64 bits long, then might be it is group 3 for 64 bits, right? For 128 bits, let's say it is 5, so you have to select 5, group 5, right? But make sure that on both ends it must be same. That's fine. This is all about ISAC and SA, security association. You have to define all these things onto both ends and it must be same. Then after defining these parameters, like your authentication will be pre-shared key, then you have to define pre-shared key onto both ends, right? And then after you will be configuring your phase 2. Phase 2 means IPsec SA. Again same things. Here there will not be any authentication, right? In IPsec SA there will not be any authentication. There will be some protocol. Again IPsec SA is what? Is a protocol suite, right? Like for encapsulation, previously you were using in GRE itself, right? GRE was encapsulating your payload, right? In phase 2 IPsec will be using ESP actually. Nowadays it will be using ESP. Previously we were using AH, authentication header. But now we are using only and only ESP, encapsulation security payload. Encapsulation security payload. So basically ESP will add its own header onto your packet, in which it will be having source and destination address as public addresses, so that ISP will not discard your packet, because you want to allow their lane users to communicate with each other, and their lane users will be using private networks. So same as GRE, ESP will work over here, and its protocol number is 50. The protocol number of ESP is what? 50. Then for encryption, because it will encrypt your data as well, you can use AES. For hashing, you can use SHA or MD5. But again, make sure that on both ends it must be same. IPsec security association must be same onto both ends, right? So for encapsulation, here we are going to use now ESP, encapsulation security payload, and it will be using sequence number for every packet as well, like TCP, right? Don't worry about that. So here mainly there will be two phases. One is first one is phase 1. If phase 1 does not come up, phase 2 will never be initiated. If phase 1 have came up successfully, then phase 2 will be initiated. Remember, phase 1 will be inside control plane of the device, whereas phase 2 will be performed within data plane, because it will be only for your data. It will be only for your data, because traffic should go via Ceph table. That is why IPsec SA will work, phase 2 will be within data plane itself. Otherwise, if traffic is coming from the lane users, it should have went via Ceph table. But now, because if IPsec SA is working inside the control plane, then traffic has to go through the control plane only. That is why remember that phase 1 will be performed within control plane, whereas phase 2 will be performed inside data plane. Because remember, see, IPsec SA is this phase 2 will be responsible to secure your traffic to your actually the actual traffic will be secured by phase 2 only, not by phase 1. Phase 1 is responsible to just authenticate to each other that okay, is it valid peer or not, right? So now we are going to do this configuration, right? For doing this configuration now, here I'll be using IP address 101.1.1, and here I'll be using 101.1.10. Here I'll be using 102.1.1, and here I'll be using 102.1.10. In the lane of the R1, Fine. I'll not touch my ISP. The very first requirement before going to configure IPsec VPN between two remote offices, they must have a public static IP address, static public address, and they must be reachable with each other with using that static public address. Move on to R1. Let's try to communicate with R2. You understand? Fine. See, ping, not possible. Reason, it does not have any route to reach that. For doing that, let's configure you can try to communicate with, but still there is no reverse path, so you have to move on to R2 Site Vpn route. From R1, let's try to communicate with it now. See, everything is fine now. Good. Then after it, let's start doing configuration of IPsec VPN. See, we could also configure GRE tunnel, but that is not a secure way, right? So for doing that, say crypto ISACAM policy and then priority number. This is like IPsec as a security association, right? So you are going to define now ISACAM, so not IPsec, ISACAM as a security association. You can take any priority number. However, you will be defining your priority number as they specified in their question, right? So if they say that okay, priority number is 10, then you have to take 10. If they said that priority number is 50, then you have to configure it as 50. So let's say it is 1, right? And within this, you have to configure all those parameters. Like for authentication, you want to use, see, you have all these pre-shared key, RSA encryption, RSA signature. So pre-shared key. For encryption, you have all these options: -3, and AES. So you have to select best one. Then you have to define your hashing algorithm MD5 SHA. So you have to select SHA. Group, as I said, 125. Sorry, not 135, it's 125. So higher is always preferred, and make sure that both of them, both ends must support the same group. Just I'll come outside now.
You mentioned over group number
G, right? So it will be specified over there. Okay, you can use this DMVPN group 128 bits long or something like that. Here in this iOS it is not showing you these bits. In firewall or in iOS 15 it will show you that okay, this DMVPN group 5 is having this number of bits long security, right? So then after you have to define now crypto. You have to define now pre-shared key, right? ISACAM key 0 or 6, you can take 0 and encrypted, right? And then Cisco at 123, and then you can define your peer address, and peer address is what? 102.1.10. That's it. This is how you define pre-shared key for ISACAM. That's the only configuration related to ISACAM. Means now phase 1 configuration has completed. This is the only configuration of phase 1. Then you have to do configuration of phase 2, means IPsec SA. So say crypto IPsec transform set is kind of priority number. Like here also you have to define that what are you going to use, right? So allocate its any name to this transform set CCIE, and then you have to use ESP because you will be using ESP for encapsulation, right? But for encryption, what do you want to use?
yes.
And for hashing, SHA, fine. It is not mandatory to define your hashing algorithm, hashing protocol for IPsec SA. It can take it automatically, but will take MD5. But if you want to use SHA, then say ESP sharp. And mode, there are two modes only within this, tunnel or transport. In site-to-site VPN it is mandatory, it is must to have tunnel. In site-to-site VPN your mode must be tunnel. Over there in T-Shoot they can do one thing, they can mismatch your ISAC parameters, they can also mismatch your IPsec SA, and also they can misconfigure this mode as well within the tunnel. Is not it? Tunnel mode, mode must be your either tunnel or transport. Tunnel must be in case of site-to-site VPN, and by default they will negotiate with tunnel, right? By default they will negotiate. If you do not define anything, then also they will negotiate with tunnel. But if you are configuring this one over DMVPN, then you have to define your mode as transport manually, statically, right? Just come outside. I will not configure anything over here. Now if you want to define the lifetime for the security association that you built over here, right? If you want to define lifetime for that security association, for this security association of IPsec that you built right now, right? Say crypto IPsec (2 hours 7200 seconds), right? Then create one ACL in which you will tell to your device that okay, when this is source and destination, then it should go via tunnel. So actually what I want actually, that when your source is its lane, is not it, and destination is, then it should go via tunnel. So to make your traffic as intrusive traffic, I have configured an ACL, because to match your traffic you can use only and only ACL. Then create a crypto map, is same as route map. Let's say you have taken its name as test. Allocate any sequence number in between 1 to 65535. Let's say that you have taken 100. You can take any sequence number in between 1 to 65535. Then you are using here IPsec ISA camp, right? Then set transform set. Your name was, do you remember? Then set peer, and peer address is match address ACL number is. Then go to your WAN facing interface and apply this crypto map over there. Crypto map is something like route map, like you have matched everything under route map. Here you are matching everything under crypto map, and then finally you have to call that crypto map onto your interface. So say crypto map, and map name is crypto map name was test. Do show history. In same manner you have to do the configuration at the end of
R2.
Tell me. R2. Same. The only thing that you have to make changes, like now address will become 101. In source it will become inside the ACL 102, and destination will be 101. And here peer address will also become, and all interface in place of 0 by 0 it will be 0 by 1, as you can see here, right? So I have modified this configuration. Now just copy and paste onto other end. Remember, your tunnel will not come up without transmitting any data. It will not do anything actually. Like see, start capturing, it is not doing anything. Nothing. Even you can run these commands. Show crypto ISACAN as a security association is up or down, it's not showing you anything. Show crypto ISACAN and policy. that you defined over here, right? So group 5, which means 1536 bits long. From here you can see the bits, right, in this iOS as well. Then after it, it was also having default protection suite as well. So if you do not configure anything for ISACAMP, then also it will use default protection suite, which do not have very good algorithms over here actually. It is using RSA signature. However, we are using here pre-share key. Over there you can see that we are using here pre-shared key. Show crypto map IPsec transform set. By default, they will negotiate what? Tunnel. What I said to you, right? And we are using the combination of these things. Show crypto IPsec SA Security Association. Have it encapsulated any packet? Have it decapsulated any packet? Have it encrypted any packet? Have it created any digest value for any packet? And have it verify any single packet? Nothing. So what I said that without transmitting data, your tunnel will not trigger. So to trigger your tunnel, it is mandatory to transmit your data. Ping. It is not going via tunnel now. Reason? Your traffic will go via tunnel in that case only whenever your source will be your own lane. It's not it. That is why it have given this packet to the ISP, and ISP have dropped all these packets. Because without encapsulating it, because via tunnel only that traffic will go, which is having source as 101 and destination is 102 on 2R1, right? So do one thing, say source is fastest 0 by 1. Repeat. It's not it. Let's see. Just stop it. ISACAMP phase 1. In phase 1 also you are having main mode and quick mode. So don't worry about you don't need to know about that what are the differences in between main mode and quick mode. But finally see, first of all ISACAMP performed, right, and then after IPsec is doing, and ESP is there, right? ESP is there to encapsulate your packet. Before that, ISACAMP was doing encapsulation. You see, ISACAMP itself. It was using UDP port number 500, right? So this is Internet Security Association and Key Management Protocol. Right, guys? Then after it, you can see ESP is working. ESP, which means that your IPsec. See, this is your data. Where is your actual IP header? Where is your ICMP? You, even by looking at your data, you cannot examine that whether it is having ICMP based packet or TCP or UDP. Nothing. See, its protocol number is what? If someone blocks 50, it won't work. Now you can move on to R2 and you can configure this command as well. Show crypto ISACAMP SA. So you will see that it have came up now. Show crypto IPsec SA. It will show you that how many packets were encapsulated, 956, decapsulated, 956, encrypted, 956, decrypted, 956, digest value calculated for 956, and also verified 956 packet. And it must be, I mean, your count must increase every time, right? So it is increasing, which means traffic is coming via tunnel. If it is not going via tunnel, then was it possible for ISP to transmit your packet? Because it was having source and destination as private addresses, so it was not possible for ISP to switch your data. It's not it. So I hope that you people have understood. Let's go to configure, I mean to secure your DMVPN now. This is that in which, I mean this is the way in which we will configure site-to-site VPN. See, there is no GRE, there is nothing. Even I didn't configure any tunnel interface over here, did I? No. Even you can check here. and still if you do not put your source interface, then it won't communicate, right? See, check it out, nothing. So IP interface brief, there is no actual tunnel interface actually, is there? Show crypto you see, this command is really important, right? Show crypto this is really important. Show crypto, this is the only command session by which you can come to know that what is configured and what is not, what is in the source of the ACL, what is in the destination, right? Fine guys, so that's the only configuration that you need to do for site to site VPN. And I also told you that first phase 1 will be performed by ISA camp and phase 2 will be performed by IPsec. So see, that's the only thing that you need to do configure, right? Then after, let's go to secure your DMVPN now. So stop it. See, it is already configured onto this device. Actually, I'll show you simply running config of that, right? I already configured tunnel interface, CRP neighborship, BGP neighborship have came up, right? And you see, ISA camp is also what? On. Where is that? This is. Which means everything is coming up, I mean, in a secure way now, right? See what I did? Show run. Check it out. It is very simple over here as well. See, first of all, ISA camp policy and then priority number, right? Same as previously. Define encryption means phase 1, group, lifetime, then your pre-shared key, crypto ISA camp key, Cisco 123, address. This time you don't know about your peers. In site to site VPN, you are having your peer address, right? So you defined that, but this time, of course, hub doesn't know that how many peers are there, because peers will be added into your network frequently and will be removed as well. So you cannot define your peer address, particular address. So I configured 00, which means for all. For all, I'll be using this pre-shared key, right? Hello. Then after it, transform set, same as previously, but make sure that mode is configured as transport. Here in running config, it is not showing me that its mode is transport, but I'll show you here that its mode is what? Transport. I configured it manually actually. In place of mode tunnel, you have to configure its mode as transport. Then after it, in place of crypto map, you have to create profile. In place of crypto map, previously you configured crypto map, right? But here you have to create profile like crypto IPsec profile name is test. Previously you configured crypto map, right? And then in it you will call your transform set. You will call your transform set. Its name was NB set, like you were calling this transform set under crypto map, right? But here under profile you will call your transform set, as well as you can define your security association lifetime seconds is 1500, or you can make it 7200 as per requirement, right? Are you getting my point or not? And then finally you will call this profile under your tunnel interface, and the command will be tunnel protection IPsec profile and then profile name. You will go under tunnel interface and then you will say tunnel protection IPsec profile and then profile name. This is the command actually, and then finally it is profile name. Till here it is command, and then finally it is your profile name. So in place of crypto map here you are calling profile. That's the only difference. And now let me show you. Show crypto IPsec transform set. You see, oh, it must show me transport actually. Crypto IPsec transform set is NB ESP mode show crypto show running config. Let's see that it will show us transport or what. Yes, it is showing me in running config as more transport, right?
What tunnel mode?
It should have not work. It should haven't work in tunnel mode. But see, in DMVPN you will always configure your mode transport. What tunnel key? Where? Where? This one? This is for tunnel interface, not for IPsec or something like that. This is only for tunnel interface, not for anything else. Right guys, so in this way you can do the configuration of IPsec for your DMVPN. Now there is one another case also exists. Sometimes what will happen actually, just try to understand now. Guys, this is headquarters router, this is your ISP, this is your branch office 1, and this is your branch office 2. You are configuring DMVPN, but now in headquarter you are having VRF onto this for this interface itself, right? You are having VRF for this interface, and for this interface also you are having VRF. Have you understood my point or not? This time your WAN interface is member of VRF. Fine. Which means that with using VRF you can communicate with each other with using their public addresses, right? But you have to use VRF ultimately, right? Now they are having some LAN networks, and which are the member of global routing table, right? Which are the member of global routing table, and now you have to establish connectivity between them. Now you have to configure DMVPN over here. So you will try to configure here tunnel interface, is not it? Like tunnel 0 or tunnel 1. You will allocate IP address like, and it will be member of global routing table only. This tunnel will be member of global routing table. And here also you will create a tunnel, here also you will create a tunnel interface, right? And these tunnel interfaces will be member of global routing table, because their LAN networks are also member of global routing table. Only this WAN interface is member of VRF. Fine. Now in tunnel you have to specify your source. How will you do that? You have to specify your source, whereas source is a member of VRF. And the point is now tunnel interface itself is member of global routing table. How will it work? Tunnel itself is member of global routing table. Tunnel source is member of VRF. If you are having something like that, in tunnel source you will specify the IP address, right, of this interface, but along with that you will define here tunnel VRF and then VRF name. Let's say its name was IT. So it will automatically understand now that this tunnel source is existing inside this VRF. The only thing that will be needed over here, like this configuration will remain same, right? Apart from that, what will you do? Let's say IP VRF is what? IT. So go to tunnel interface, tunnel 1, then say IP VRF, sorry, tunnel VRF. Name is, that's the only thing that you have to make changes. Now see, do show, it will show you that tunnel VRF IT. Your neighborship will go down because in IT we do not have anything, right? Hello, right now we are not using this VRF, so do one thing, just remove it from here, right? So you have to be very careful if you are using VRF over there, so you have to specify this command over there. Apart from that, now there will be some changes in security as well. Like if you are using here VRF, your tunnel source is VRF interface. I mean, tunnel source interface is part of VRF, right? In that case, if you are going to configure your security parameters, like, do you remember that we created phase 1, phase 2, and then we created a profile. Finally, we called that profile onto tunnel interface, right? But if you are going to configure phase 1, there will be some changes. If you are using VRF over here, right? If you are using VRF, then there will be some changes. Like, you see this command, I mean, first this book, it will remain same. There will not be any change in this configuration. But whenever you will define your pre-shared key, you will not define your pre-shared key in this manner. If you are using VRF, you will define your pre-shared key in this manner. Now see, crypto keyring, and then keyring name. Let's say it is CCIE, and then it will ask for VRF name, VRF, and then let's say it was IT, and then define pre-shared key address for what? For all. So say then key, and then key Cisco in this way. You will do that. This is the only change that you have to make. Otherwise, all other things will remain same. In case of VRF, means pre-shared key must be defined in this manner. If you are using VRF, you have to create keyring. Without that, your phase 1 will never come up if you do not configure this configuration, right? I mean, if you do not use keyring, because you have an option of VRF under keyring only, you do not have option of VRF if you are doing the configuration of pre-shared key in a straight manner. Like if you are saying IP crypto ISACAMP key, and then you do not have an option of configuring VRF, right? So this is the only change that you have to make over there.
So why do you configure VRF in branch?
Let's say you are having a default route, right, from this service provider, right, from this service provider, but internet is coming now. See, this R2, R3 and R4, they are having a default route towards ISP, but R1 is having internet connection, right? R1 is, yeah, and now you want to receive the default route via EIGRP. And here also you have configured a static default route towards this service provider just to reach its WAN IP. So there will be two default route now which will be followed. So in that case, to solve that problem, what can we do? We can configure a VRF over here, so that static route will be configured within the VRF. And whenever it will learn that default route via EIGRP from headquarters, it will learn within global routing table. Forget about this ISP, this router, like it is ISP. No, it is not ISP. It is simple service provider. Internet connection is in headquarter only. This headquarter have taken from any service provider that internet connection, right? So you have to provide internet from headquarter to now all spokes. How will you do that? Right? So that's the only thing that you need to be you need to know in DMVPN. Now your DMVPN is completed, your IPsec VPN is completed, site to site VPN, right? Now I'm going to tell you something related to AAA in security, right? Fine. See, if I come outside, there is no authentication for console. To configure authentication for console, as you know very well, you learned it in CCNA. Create a username, go to line, yes, login, but if you want to configure authentication from AAA server, you have to enable. You will be using either Radius server or TechX server. You have to do that. Configuration externally, that this is my Radius server and this is my TechX server. But here you do not have any TechX server. You do not have any Radius server, right? So finally you have to use local database for authentication. But I will create AAA list, authentication list, like in this manner: AAA authentication login, for login, right? List name is what? CCIE. Group Radius, group TechX, and then local. Do not forget about it, right? And then go to line console 0, login authentication, and then AAA list name was. Now it will try to authenticate from AAA, not local database. But finally, of course, it will get authenticated from local database itself. See, Cisco. It's not it. In this way, you can configure AAA authentication for console. Now, if you wanna change these prompts, if you want to change these prompts, you can change them. Like you can say AAA authentication, username prompt. You can type anything. Then AAA, right? Then banner MOTD, and then once again $, to save it. This come outside. See, this is restricted area. Got it? In same manner, you can enable SSH. To enable SSH, it's mandatory, right? Then say crypto. SSH will get enabled now. Then you can go to line. If you want that people should be able to access it via SSH only, then you can say that list name. If you want that remote users should get authenticated from the AAA server, right? That was
Transport into SSH remote PC.
just to allow external users to access this device via SSH only, not via telnet. You cannot access it via telnet now. Then apart from it,
As soon as we configure this command transport into SSH, that login authentication gets removed.
no,
Because we already configured that.
no, I configured it under console 0 only. Now you do one thing, move back onto other device, something like R2, and you can try to take SSH of that device, right? Like SSH-L, username Cisco, and then IP address was
What is this minus L for?
what?
SSH minus L. Minus L.
It's for login, I think so. SSH log in using this user. That is I specified here, Cisco. Login with using this username, right? That's why it directly asked me for keys.
You can just directly set and get IP address.
Yeah, you can also do that. Like SSH usually SSH is always done in this manner only, like, but first of all define your username and then your IP address, right? Now you got MOTD banner over here, but you want to use some different banner for login for those users who are accessing this device from remote location. So for doing that, you can come onto R1 and then you can say banner right? That's it. Now if you go back to, let's say, see, the point is it is showing you both banners, MODD as well as login banner. However, it should show us only and only login banner, right? So for doing that, actually you can do one thing. You can go back to R1, line VCY024, no banner, oh my god, MODD banner. So no MODD banner. So it won't show you now MODD banner. Go back to, and once again say, see, it will get enter, but this time it won't show you MOTD banner. It will show you only and only login banner.
तर R1 पे check कर सकते हैं कौन सा user access कर रहा है.
Yes, you can do one thing onto R1. You can say IPSSH logging events. This one as well, right? You can move on to R2. Cisco. What is it saying? You can also enable this logging onto your devices, so that in future if anyone try to access this device from this, then we can also do some more things over here like IPSSH. You can also configure source interface, like I want to use loopback one, however loopback one is not there, but you can use something like that. Then IP, then IPSSH. You can also say max startups, which means that how many number of connections to be accepted concurrently, how many users can access this device simultaneously. Two, not more than that, right? So in this way you can do this. IPSSH authentication retries 3. Right? So you can also do that. And fine, that's enough. Then within line VTY, you can move under line VTY 024, and then here we are also having this command access class. Do you remember the uses of this class? I mean this command. You can configure your ACL over here. You can allow only some specific users to access your device from remote location. You can call standard or extended ACL, whatever you want, right? Like one in which direction? In. Or you can also configure it in outbound direction as well, right guys? So now you can do all these things over here, and I have performed all these practicals of SSH over here. I have taught you that how to do the configuration of SSH. Then if someone asks to change your SSH version, then you can say IPSSH version, and then you can make it. Got it?
R1 से user को disconnect कर सकते हैं.
Clear? You can see your line number and then you can clear that, like show, right? So clear line VTY 0, show users. Right? Any problem in it?
Can we simulate backup server?
What?
Can we simulate a server? Because okay.
Never. In RNS, there is no implementation of either TechX or Radius.
No, is GNS capable of that?
Yeah, of course. Even we performed, I think some of you took, not you actually, CCNP switch class from me. I was used to use these things during CCNP switch for .1x authentication. Like if you wanna configure dynamic VLAN, then you can do this configuration. You can ask to your Radius server to configure that. But here we do not have that practical. Even in lab and T-shoot also, you will not get actual TechX or Radius server. They will always use local database for authentication, right? Now we can also configure all these things as well, like line VTY 024, and then you can also define a privilege level. Like if someone is accessing it from remote location, then for all of them you can define their privilege level as well. A privilege level 5. sorry, privilege level 5. However, this user is having privilege level, see, show it's 15, and currently we are logged in here with using username Cisco, but I will log in with same username from remote location. See what is happening now. Show I can't move. Show IP interface. Yes, that is show run. Wow. Like this. Come outside. Any problem? Okay. So in this way you can do the configuration of SSH. In same manner you can also configure HTTP or HTTPS as well. Like IP, HTTP, IP, HTTP for HTTPS. Now you can access this device from HTTPS world. I can access this device by opening like here my Windows Explorer, or with using Internet Explorer I can access my devices with using HTTPS now. But I must have reachability with that, right? So this way you can enable it. Then apart from it, see, if I'm creating a user like with the name of test, I define privilege level, sorry, test username, test privilege, password is also God. I define privilege level 5. See, line console 0, login, just wait for a moment. Let me remove that configuration from here.
Line 1.
Actually here it was privilege level 15. Remove it. Find out again. Just wait. Say login. What? don't know why. I mean, now it's not it's not picking this command actually. But actually, I wanted to show you that even you can modify the privileges of privilege levels as well. Privileges of privilege level as well. Let's say that there is a user with privilege level 5, but you want to allow that user to configure IP address onto interfaces. To configure, I got my point. For doing that, you do one thing. Say privilege exec level 5 configure, because you are already in user mode, right? Configure terminal. I want to allow this command. What? Okay. Configure terminal. Then in configure mode level 5 for privilege level 5, right? I want to give interface mode. Then you will be inside interface mode. So privilege level interface level 5 IP address. Then you can also provide shut and no shut as well. In this way you can do that, right? So let me do this configuration. Do show history. I'll be moving on to R2 now, and I'll do this configuration here on to R2. See, now I'll create one username, Cisco privilege 5, password Cisco, line console 0, login, logout. Just come outside. Cisco configure terminal interface. But apart from that, you cannot configure router OSP here. Interface FA0 by 0. Apart from shutting down, no shut and IP address, you can't do anything else. Only after IP there will be only address. Right, so in this way you can define your privileges. However, in production environment we are doing all these things with the help of Radius server or TechX server. Fine. AAA is complete now. This is kind of authorization, right? So I think that's enough for today. See what am I